Alrighty, eighth grade math. We are going to talk about classifying numbers, and I want to say thank you to those of you that went ahead and tried this assignment when you didn't really know how to do it. That is the best way to learn something. Okay, if you wait until somebody teaches you, then you actually learn a little bit less than if you try it and then they teach you. Even though it's a bit more frustrating, maybe boring at times, but uh, it's good. It's how your brain grows. And it gets a little bit stressed. But like I said, if you just take a screenshot that you don't know how to do it, just take a screenshot, send it over to the traffic light problem, and we'll go over it in class. Right now, we're going to go over it right now. So let's look at this problem. Is the square root of 32 rational or irrational? So please write those down. Rational. What does that mean? That means can be written, as a fraction. So we have spent a lot of these first 3 weeks writing numbers as fractions. Some of them were terminating decimals, some were repeating decimals. We took, 0.32 repeating. We learned that that's 32 over 99. We did the process. 0.17, that's 17 hundredths. That would be 17 over 100, right? We have written a lot of decimals as fractions, and we've even written fractions as decimals. So now what you need to know is those things are rational numbers. But even like 7. 7 is 7 over 1. That's a fraction. That's rational. How about negative 82? That is a rational number because it can be written as a fraction. So it's about could it be, not necessarily is it. But if it is a fraction, then it's a rational number. So like 1/2, so this big circle of things are rational numbers. I'm also going to include the square root of 64 because that is the number 8, which is 8 over 1, a fraction, a rational number. So lots of different types of numbers that are in the rational category. But there are some that are not. So we have another circle that is actually very large as well, of numbers called irrational numbers. It's crazy. There are so many numbers that you cannot actually write as a fraction. And one of those numbers is the square root of 32. Another one would be the square root of 79. Another one would be the square root of 26. And any non-perfect squares. So you remember that list that we made? And we were, investigating what perfect squares are. Well, any non-perfect squares are in the irrational circle. But then there's some other ways you can get into this irrational circle if that's where you want to be. You could have a pi, it could be connected to a pi, like pi is the number 3.14159, It goes on forever with no pattern. So pi is the irrational, but also 3 pi. Like if you're a rational number, but you have a pi with you, now you're irrational, so 3, I already did 3, let's do 7 pi, 3 halves, 3 halves pi. If there's a pi, it's irrational. And so we can add if we see anything else that I haven't mentioned. I think I've mentioned that, but if I haven't, we can add it. So this irrational because it's not a perfect square. Next. Now look at this. What is the square root of 121? It's 11. So you can see it's rational. So before you classify, simplify. Let's write that down. Before you classify, simplify. Yeah, I can save you a big headache. Let's do one more. 6 1/2. Well, that's rational because it's a mixed number. It's a fraction. It's not a non-perfect square. It doesn't have a pi with it. So there you go. Pi over 2. Irrational because it has that pi with it. So it will not be rational. Okay, so go ahead and see what you can do with that one. And any ones that are tricky for you, just post them as a traffic light problem. Okay, let's move on. This one, we're moving on, but not completely because we're just adding categories. So we have rational, irrational, but then we also need to talk about integers and whole numbers. So let's get our circles here. So we got irrational. Nice thing about irrational is that's everything in the circle. But inside of the rational circle, oh my, I need to make a bigger circle. I wonder if I could use shape. Okay. So I'm just gonna make a big rational circle because as you saw, there's a lot of different types of rational numbers. Okay, so the smallest group inside of the rational is the whole numbers. So 0, 1, 2, 3, 4, and on like that, with no decimals, no fractions. Those guys are called the whole numbers. Okay, so they're inside of the rational circle, but they are also inside of a slightly bigger circle I like to call, you know what it is called? Integers. Because last year you learned about adding together positive and negative numbers, right? So the whole numbers don't include any negatives, and then the integers, you get the -1, -2, -3, -4, and on like that. Still no fractions, no decimals, but I want you to notice that integers include the whole numbers, right? So integers, should probably write that down. Somebody is going to be a little bit confused by that. Integers include whole numbers. So if I get a number like, let's do two examples. I get the number 7 and the -7, okay? 7 is a whole number. But it is also an integer. Because if you look closely, the whole numbers, as I said already, are in the integer circle. -7 is not a whole number because it's outside of the whole number circle, but it is in the integer circle. So -7 is only an integer. +7, because of the positivity, gets to be a whole number and an integer. Isn't that wonderful? What type of a number is -12.123 repeating? Because it has a decimal, is definitely not a whole number or an integer, but because it does have a pattern, that a repeating pattern, I should say, Ms. Newman is gonna come down on me, because things could be a pattern that don't repeat. We don't have to talk about that right now. So rational. Let's try another. This stuff 3 2/3. Okay, so 3 2/3. So it has a fraction, so boom, boom. It's not those, but it's definitely not irrational. We talked about it's rational. It's rational. All right, give me another. Okay. All right. This is a good one to do. I'm not looking at it. So this one is a good one to do because, like I said, we want to simplify before we classify. Okay. So the square root of 25 is what? It's 5. And so we know it's not irrational because it's just 5. And actually 5 is a whole number, which means it's also an integer, which means it's also rational. It's in all three circles. Okay, so now we're going to go on to approximating square roots. Okay, so going back to our perfect square list, some square roots are really easy to know because they're in the list and they're whole numbers. Some, actually most square roots are not whole numbers, but they are in between whole numbers, okay? So if we have our list, 134, I know that I have 121, the square root of 121 is 11, and the square root of 144 is 12. And the square, and then 134 is in between those two, because 134 is in between 121 and 144. And so we want to say how far away is it from each? So it's 10 away from 144. And then if I do 134 minus 121, how far are those numbers away? We get 13. So it's close to being in the middle, but it's a little closer to that one. So what is it going to be? What is the square root of 134? It's closer to 12, but remember 12 is bigger than it. So it's actually going to be 11 point something. If it was directly in the middle, it would be 11.5. But it's not directly in the middle. It's a little bit above the middle. If it was closer to 11, maybe it'd be like 11.1 or maybe 11.2 or maybe even 11.3 if it's closer but a little far. I'm going to say because it's a little bit closer to 12, but still kind of in the middle, I'm going to say 11.6. But remember, we're just approximating the square root. So let's see. I get it. Oh, don't even have to go that far for this problem. We just have to write 11 and 12. Okay. That one wasn't too bad. But you can see with this one right here, without using a calculator, choose the statement that best describes the value of 174. So we have 174. What two square roots is that in between? Well, I remember that 169 is 13 and 196 is 14, the square root of 196. So now I'm going to, if I do subtraction, I can see that these are 5 away from each other. And what's 196 minus 174? That is 22 away from each other. So 174 is a lot closer to 169. That means the square root of 174 is going to be a lot closer to the square root of 169, or 13. And I want you to notice that the other one we just did was closer to the top number, but still it started with the bottom number. Did you see that? Every approximation will start with the bottom number, because even if it's closer to 14, it can't be greater than the top. So if it was in the middle, exactly in the middle, like these numbers were the same, we would say 13.5, but it's not. It's definitely closer to 13, so maybe 13.1, maybe 13.2, just approximating. We definitely know it's going to be between 13, and 13.5. So say A. Listen. And there you go. Okay, so give that one a try and come to class ready to practice and we'll just get better and better. Okay, we're just gonna do one more here because these are kind of the same thing. Just I'm gonna do it without a calculator anyway. Um, so this is gonna take what we just did and is going to kind of